So here's a function, okay, and basically I've got a few things I want to find to do with this function. Okay, I want to determine the equations of any asymptotes. I want to find the position and nature of any stationary points. I want to find its axis intercepts, and so when I do all these things, I can then sketch the graph. Okay, so first off, we're going to look at the asymptotes. All right. So I've got the function here. I want to factorize the denominator so I can get the asymptote. So I would say change it and make it look like this. Factorize the bottom, so the factors of -2 that add to -1 would be -2 and +1. So that factorizes to this. Okay. All right. Now I can see from that, all right, that I would have two asymptotes. I would have one at x equals 2, because 2 take 2 would turn this bracket into 0, therefore turning the denominator into 0, making it undefined, therefore it's asymptote. Or if x was equal to -1, I would also have an asymptote, because that would turn this bracket into 0, turning the denominator into 0, and so that would give me, so I have vertical asymptotes at x equals 2 and x equals -1. Okay, so they're the vertical asymptotes. You use the denominator to find the vertical asymptotes. So horizontal asymptotes, okay, I see, okay, when's there a horizontal asymptote? All right, what I'm going to do, I'm going to see how this function behaves as modulus x approaches infinity. So, okay, if I made x become really, really big here, okay, so really big towards infinity, this denominator gets huge, doesn't it? As x approaches infinity, this denominator gets huge, okay? Now, a huge denominator means a very small number, small function all up. So the bigger the denominator gets, the smaller the function, okay? So if this is heading towards infinity, you can see that the function approaches 0, okay? So as modulus x approaches infinity, the function gets closer and closer to 0. Therefore, I have a horizontal asymptote at y equals 0, okay? Y, the function, so right here, y, as x approaches infinity, this function becomes 0. So my horizontal asymptote is at y equals 0. My vertical asymptotes are at x equals 2 and x equals -1. Okay, so next I want to look at the stationary points. Okay, so stationary points, local maximum, local minimum. You know that to do this, I have to look and get a sign diagram of the derivative. Okay, so the derivative of this function, I'm going to need to use the quotient rule because it's a function on top of a function. Okay, so using the quotient rule, we've actually done the derivative of this function in the past example, but I'll just do it quickly here. Okay, so I get the derivative of the first part, which is 3, okay, multiplied by the second part, which is x squared minus 2. Oh, sorry, the denominator, not the second part, I should say. Okay, and that subtracts the derivative of this, which is 2x minus 1, multiplied by the numerator. Okay, and that is all over the denominator squared. Now, denominator we'll write in factored form. Okay, so this whole thing here gets squared. Okay, this is the quotient rule. Okay, now we need to neaten this up, so we expand the brackets, gets me 3x squared minus 3x minus 6, okay, minus, then we do FOIL on this one, that gets me 6x squared minus 21x plus 9, okay, and that is all over. What does this become? I can just write like this, x minus 2 squared, x plus 1 squared. Sounds right, okay. Now, neaten it up a bit more, collect the like terms, that gets me negative 3x squared plus 18x minus 15, all still over x take 2 all squared, x plus 1 all squared. Okay, so I'm going to neaten this up even further, take out negative 3 as a common factor on the numerator, so that's going to give me this, go onto a new piece of paper, so the derivative is equal to, so I'm taking negative 3 out as a common factor, and that is going to give me negative 3 out as a common factor, so multiply x squared minus 6x plus 5, and that is still all over x take 2 squared x plus 1 all squared. Okay, now factorise the top here, and that gets me, I get the factors of c that add to b, so the factors of 5 that add to -6, that'll be -5, -1, so that factorises to x take 5, x take 1, and that is still all over x take 2 all squared, x plus 1 all squared. Okay, so now I can get my sign diagram. Okay, so I know this. I know I've got an asymptote at -1 because that will turn this denominator to 0. So let's do this. It's an asymptote at -1. I know I've got another asymptote at 2. So let's just put that here. So that's another asymptote at 2. I know that if I make x1 here, the numerator gets turned to 0, so I've got a critical value at x equals 1. And if I made x5, this whole thing gets turned to 0, so that means that's another critical value. So we'll put that there. 5, okay? So this is my sign diagram. I now have to sub in different values in between these to find if I get positive or negative answers. Now, because we've done this before, I'm not going to show you the substituting in, but you're just going to have to trust me. If I sub a number less than -1 into this derivative, I get a negative answer, I then get a negative, I then get a positive, I then get a positive, and then I then get a negative. Okay, so you can see this. You can see that the function is decreasing before the asymptote here. This isn't a local maximum minimum because it's an asymptote, it never touches, it never passes, okay? Then it's decreasing and increasing there, so that's going to be a local minimum. Okay, then it's increasing and decreasing there, so that's a local maximum at x equals 5. Okay, so I've got a local min at x equals 1, and when I sub 1 back into the original equation, remember you don't sub it into the derivative, I sub it back into the original, which was this one, so it'd be 3 times 1, which is 3, okay, so I sub it into there, I get an answer of 3. Okay, so I've got a local min at 1, 3, and a local max at 5, and I sub 5 back into the original equation, f of x, and that gets me an answer of 1/3. So 5 1/3 is where I've got local max. So that's the position and nature of any of the stationary points. The next part, I have to find the intercepts. How do you find the intercepts? Well, pretty easy. X-intercept occurs when y equals 0. Yeah? So what I do is I make the function 3x over x squared take 2 equal to 0, and you can see that's going to be 3x take 9 is equal to 0, so x is going to be equal to 3. Okay, so that is the x-intercept, x equals 3. If I want the y-intercept is when x is equal to 0, easy as. So I get the same function, and so I just go, alright, what happens when x is 0? Well, it's going to be 3 times 0 take 9 over 0 squared take 0 take 2. That's going to give me an answer of -9, -2, which is really 4.5. Okay, 4.5. Okay, so the y-intercept is at 4.5. So now I've got everything I need to have to sketch this graph. I have got the asymptotes, I've got the maximum and minimums, I've got the axis intercepts. Okay, so let's sketch the graph. Okay, let's use what we found. Asymptotes at -1 and 2. Okay, so let's go. So there's an asymptote there. Sorry for the rough drawing, I'll just do this quickly. That's at -1. Okay, and what was the other? Oh, that's at -2, I've done it. Well, you know what? If that's 1 there, we'll put this as 2. We'll go, alright, so that is 2. So that's your asymptote there. Okay, what else did we find? We found that it intercepted at, so the y-intercept is 4.5 and the x-intercept is 3. So 4.5, let's say that's 1, 2. This is going to, 1, 2, 3, 4, 4.5. We'll call that 4.5. And if we call that, we'll call that 3. This is going to look a bit odd because I got the scale wrong on my thing, but that's alright. So we know it crosses there, okay, and we know we have a minimum at 1, 3 and a maximum at 5 1/3. So minimum at 1, 3, that's our minimum, and a maximum, what was it, at 5 1/3. So let's just call 5 up here, okay, 5 1/3, so sort of here. So here's what the graph is going to do, and I know that, what else did I find? That y equals 0 was the horizontal intercept. That's the x-axis, isn't it? The horizontal asymptote was at y equals 0. So I know this graph will do this. Okay? It will do this. Local minimum. Crossing at 4.5, the local minimum there. It crosses at 3 with a local max at 5 1/3, so it's going to go this and approach that. So there's the sketch of the graph. Sorry that was a bit rushed and rough, but you get the idea.